Lady and gentlemen, I present to you Daniel Wittenberg.
So it seems like we have quite a few scaling presentations this year, so it's good we're all getting to share some good info. This was a presentation we kind of started last year, and some things have changed. Some things are still in flux because it's quite a big network, so it's like the Titanic. Trying to make changes doesn't happen very fast. Little background, I guess I've been doing Linux and Unix for many, many years and all sorts of different other technologies, so it's doing the monitoring kind of fit right in because I got to understand a little bit of the different technologies. I guess some of the topics we'll go over just kind of cover the whole range of things that we looked at when going through all of our performance and issues and problems that we've had over the years. And this is slightly outdated, but pretty close to what the architecture looks like. The big difference between what's here and what was last year is there's actually 15 servers now. We actually ended up adding some more physical hosts for some more capacity and oncoming new services and stuff like that. So it was easier at this point just to throw some more stuff on there. One other slight thing I guess we did change with this too is we ended up having to take some of the Splunk stuff off. So not every server runs Splunk now, mainly because each server was generating over 25 gigs of log data a day. And they complained about the cost of the Splunk license for that. So we kind of went down to just a couple servers in each data center as kind of samples. So we still end up doing a lot of log parsing if we want to go back and see if something happened somewhere. This was a sample of one of our setups of CheckMK. With about 1.5 million service checks. It fluctuates quite a bit as servers come on and off and services get added and removed and changed, but this was one of the bigger days that I saw when they were making a bunch of changes and still having a lot of problems, it looks like, that day. So this was off our main server, so it oversees all the Nagios servers, all 48 of them, from one interface. Yeah, this was a little bit older one too, because we're running 1.2.0 of multi-site now. Hardware versus VMware. We ran into some problems early on. When we started the implementation, it was originally scaled out before I was brought on, and it was tried to use several VMware servers. And when we started doing some scaling testing early on, we realized that it was not going to work. I've got some numbers coming up that will kind of show some of the differences. But after working actually with some of the VMware engineers, what we came back with was the high rate of forking checks. The checks and the NRPE and everything that was being forked was a lot faster rate than what VMware could handle. So we found that even a 10-year-old server physical box could outrun a 8-core VM. Kind of sad, but it wasn't good. So one of the things that I put in red here was something that changed, and we kind of started playing with live check a bit from live status to see if we could just kind of easily mitigate some of that forking rate. We ran into some serious problems with it, locking up and not working right, so it never made it past QA testing and on a small scale. So we kind of ripped it out and said, all right, we're going to live with it for now. We're hoping 4.0 will fix that. So that's kind of the plan at this point, start stress testing 4 and see if we can go with VMware again. Because one of the big things we liked about the VMware is it keeps the HA and failover stuff much, much simpler. We don't have to have very complicated setups for failover, and when it doesn't fail over, shared resources. Can turn on some of the in-memory copies and stuff, so if one server goes down, you see a minor hiccup and the other server's up and running, and keeps the OS and config and storage and all that stuff much, much simpler. That's kind of been one of our requirements from the beginning, is keep it very simple. We don't like hacking around a lot of stuff if we have to. The CPU requirements, yeah, when we did our testing, we found that even lots of little CPUs performed a lot better than smaller amount of big CPUs. So we're hoping that that'll probably carry over with 402 with the worker processes. Memory. Even with Nagios 3, we found that the memory utilization was really good. Most of the servers only have 4 gigs of RAM, and it still operates pretty efficiently. I think we're up to a 256 meg RAM disk, and it still has plenty to run. I think that RAM disk is probably a little bigger than most people that I've worked with, but the other big thing I've seen affect that is the plugins. We've had some people write some really bad plugins that would very quickly eat up available memory. So that's one thing that I do tell people, is when you're writing checks, make sure you write them really well. Since most people don't use C, which will run a lot less memory, but most people I know are writing them in either like Python, Perl, or Ruby. So it's just making sure that your algorithms are good. Disk I/O. This was a big one that I think a lot of people have noticed, and why a lot of people use the RAM disk. With 4.0, I don't think this is going to be an issue at all. Almost all the disk I/O is gone. So there was some talk about even taking out there's a default in the RPMs that we put in that will make it real easy to turn on the RAM disk. You can just specify it in etc sysconfig Nagios, say use RAM disk, and it turns it on automatically. We thought about ripping it out, but left it in for now, because there still could be some people using the check results and stuff like that. So we've left it in for now, but it's probably gonna go away. But that'll be a great improvement with 4.0. Here were some of the performance numbers that we ran through. We had a couple physical boxes, one brand new one and one really old one, that we did. And you can see some of the numbers of 800 and 1,000 hosts, and some of our service latency checks. They were getting pretty high. So even our latencies were getting really low on the 8-year-old boxes as compared to ESX. And we were really surprised that we could only get about 1,000 hosts before it really even got that bad. The R710, this one went really well. We couldn't find enough stuff to throw at it to make it hardly even work. And so we tried to configure it about the same as under ESX. It was actually going to be an ESX server at some point, but it just came off a truck, so we got to play with it. So one of the things that has changed in the last year is we're actually still in the middle of migrating to Red Hat 6.3. There's a lot of infrastructure stuff that has to change to support that, so it's taken us a while to get there. So I think about half of the environment right now is upgraded to 6.3. And so far we haven't seen a big change from that. I think the performance is a little bit better, and we definitely have some better monitoring tools. So it does help when we're starting to look at stuff. So one of the recommendations I always make to people is to definitely look at what services you're running. I know a lot of people tend not to pay attention to how they build servers, but at least the bigger environments, a lot of times you'll end up with a group of people that build OSs, and then you layer your app on it. And that's kind of what we started with, and started questioning why all these services were running that may or may not actually be used for anything. So I think stripping down any running services to save on, well, disk I/O, which, like I said, don't think there'll be much of an issue anymore, but memory, CPU, all that stuff, anything that could potentially cause problems. Like I said, it goes back to the keep it simple. Strip it down if you don't need it, get rid of it. Creating the RAM disk in the RC script, yeah, this was something that was put in the new RC scripts that you'll find out in the new builds, and turned on in 4.0. Well, it's not turned on in 4.0, but it's in there in the 4.0 RPMs. This was roughly the code that we used. I don't know that that's actually what made it into to the actual RC scripts because we variabilized a little bit more to put stuff into etc sysconfig Nagios, so you could specify whether you wanted the RAM disk or not, how big you wanted it. But that's basically the code that we put in there. The U-limit restrictions, we ran into that pretty early on as we started to tweak things a bit. We were running out of the number of files, processes, so usually we try to tell people to just make things unlimited for the most part for the Nagios user. I think this is going to be even more of an issue with 4.0 because it runs so much stuff and so much faster. I think it's going to fork a lot more stuff, mostly from the checks. So that's one thing definitely going to watch for if you don't have it set now and start to look at 4.0. From some of the stuff I've seen so far, it can open a lot of files really fast. Renicing daemons and services. This was one that also bit us quite a bit. We would notice that by default the RC scripts would run it at a normal priority, and some simple stupid things would sometimes trump it and cause problems. So we've tried to exec the priorities on it a little bit higher, and some other things turned down, like Puppet was one we noticed that took a pretty good chunk of CPU every time it ran. So we changed the nice level on Puppet because we don't care if it takes longer. The monitoring is a little more important. So even things like running the PNP processing, there's potential we'll move that off onto some different reporting servers. It's something else we've been looking at. For NAT right now, on the mantra of keeping it simple, we've kept every server pretty much a standalone server. So it does its own PNP processing, it does everything. So if the only thing that can really affect it going down is Puppet. The Puppet doesn't push stuff to it. Otherwise, it's all off on its own. So, and that's another thing I tell people too, the watching your running services. So I think there's a lot of tweaking if you are having issues of just sitting and watching what's running on the system, doing a lot of profiling. We were kind of surprised at some of the cron jobs that we're running that we didn't expect would cause problems, that after sitting and just watching performance and wherever we saw issues, what cron jobs would pop up and what scripts would actually take more CPU than we expected them to. And so a lot of detailed watching of what your system is actually doing. Currently right now, there's actually still some 3.3 out there. Along with the 6.3 Red Hat upgrade, we're also rolling 3.41 on all the systems too. 4.0 is sort of in a test environment, but more of more dev. We haven't done a whole lot with it yet, mostly just functionality to make sure it will actually start up and do some verification and that kind of stuff. But we're expecting actually to start putting it more in a QA environment next week, start throwing some real load at it. And with 3.4.1 too, we had the advantage that most of the patches that we had submitted or worked on were included in 3.4, so that made it really easy for us that pretty much out of the box RPM builds. We still had some changes in the RC script that we put in. Those were actually incorporated into the 4.0 stuff, so starting at 4.0 we'll have almost no custom changes then, so that'll definitely be nice for us, I think. So some of the other suggestions that we did, pre-caching of objects. So every time we would do a verification or a check, we did pre-caching to make sure that we could restart faster. Rewrite the RC script to optimize restart time. That's something that's also in the new 4.0 stuff. And you don't have to use the -X now, because we had problems where we had so many service dependencies and checks that we could never actually run a verify because it would never actually finish. That's also fixed in 4.0, so I got some performance numbers on the changes in that, so we can see those a little bit later. One of the big changes that we added in was also not being able to restart if there's a broken config. We had a lot of cases where things would get pushed out that part of the problem with automation is sometimes if there's data problems, your automation can break things really fast. And so we have automated crawlers that crawl the environment and see where all the parent devices are and build that whole map of topology. And we had some cases where it wouldn't exactly discover things correctly, so by the time it wrote the config file, it would write like part of a config file and not the whole thing. And so sometimes things would get pushed out and then it would restart and then the whole thing was dead. So what we do right now is if you actually give it a restart command, it will actually do a check before it shuts down. So it won't allow you to start with a broken config. So it'll spit out a message saying it's broken, but it won't actually kill your service. So then we actually put in a Nagios check, because it does go out and actually touch a temp file and tell you that there's a broken config. So we actually have a Nagios check runs from another Nagios server that looks for that and tells us, hey, you have a broken config on the server, go check it out. So usually, like I said, it almost always came from the automation on the back-end side generating bad configs. The use of macros, that's another thing that I'm hoping will be fixed in 4.0. Haven't done a lot of testing with it yet. But we had basically stripped out almost all the use of macros everywhere. Because even things like in your resources config, pointing it to where the plugins were at, we after doing some profiling, we noticed that it was just constantly going out and resolving those over and over and over, and added a lot of latency to running a batch of checks. So we went through all of our templates and all of our configs and stripped out everywhere we could find that we could use a macro, except for some of the dynamic ones that we had to use, like host address and that kind of stuff that you kind of need. Yeah, the environment macros definitely is another bad one, but we talk about that a little bit later. Yeah, removing the CGIs, as some other people have pointed out too, that the CGIs can be a huge resource hog. And we saw that very quickly when we were starting to do some demoing. We would get 10 or 15 people from second level support going in there and all hit and refresh at the same time, and then all of a sudden the server would fall over and we couldn't figure out why, and didn't take long to find that problem. So I've actually got them disabled in Apache except if you're specific users. So there's 2 or 3 of us on the kind of the core support team that we can get in and see the CGIs and see what's going on if something happens, but otherwise we don't let anybody else even hit them. So if you've got people that could, like somebody, I can't remember who had the story about adding the widget into Firefox and crashing their system because of something querying the CGIs. So it might be a good idea just to completely disable it so they can't use them. We also had a big long discussion with our OS support people because they were running full OS images like once a week and constant backups of stuff, and from their perspective it was to protect them against people that made changes a lot on their servers and didn't tell them, and then it would blow up and then they'd get in trouble. And but we designed everything to be fully automated through Puppet from the beginning, so we actually got them to completely disable all the backups, all the images, nothing. And that helped a lot because we noticed even with their stuff set to the lowest priority, just the disk I/O of scanning the disk for filed changes and all that stuff was a huge overhead. So everything was built automated in Puppet. If a machine blows up, which we have had machines completely fall over and fail. They take a hot spare, give it the new host name, run Puppet. Within an hour, we're usually back up and running. So that's not too big of a deal if it's set up right. Logging level was another one that we noticed can really bite you really fast. We've had in a couple cases where people turned on higher levels of debug in even some of the add-ons, not even in core. And even those were enough to slow the system down, to run the disk I/O up, and can really hurt really fast. So if things just suddenly start getting slower and you don't know why, you might see what somebody's done with logging. Keeping your comments limited. This was something we ran into within multi-site, and I'm not sure that it affects anything else, but this one took us a while to figure out because multi-site would start to load the web interface and then just kind of stop. And after doing some more tracing, we found that it was the comments field that is in the hover over. So you don't directly see it, but when you hover over it, it gives you the big long thing. And we found where Sometimes systems that were flapping, going on and off, on and up and down. Our ticketing system automatically adds comments when it's doing things, and we'd get like 100 comments in there, and then your multi-site would stop and wouldn't load anymore. So we have a cron job that actually runs every hour and kind of scans for, I think what we ended up with is it can't be more than 30 days old, or it can't be any more than 10 comments. So if something's going crazy, you may only have the last hour of data, but it keeps it below 10 comments, and that seems to make it pretty happy at this point. Yeah, the status update. I said some of this stuff, it's going to be interesting to see how it affects it in 4.0, but I suspect that won't have that issue anymore, so that will be kind of nice. And enable environment macros. There's some discussion of that just completely going away. I've not personally ever seen a need to use environment macros, but I'm sure there was at some point. Some of the plugins that we use. Check on RPE a lot. Check log files a lot. We're using check log files a lot on Windows and on Unix. Hardware management stuff for HP, Dell. Have a lot of database stuff. We actually have Oracle, MySQL, and Postgres to watch over now. The check BS I think might have actually gotten upgraded. We rewrote some of it to add performance data. We're pretty big on collecting any performance data that we can. So any plugin that we used, we try to review it, and if it had anything of use, we returned it for performance data. Some of them we rewrote, some we put wrappers around them. We wrote kind of a nifty one that can't remember if I ever got to push out or not. Auto service that would just basically look at the services running, and you could just give it a service name, and it would automatically tell if it wasn't running it was supposed to. It would restart it for you. So it was pretty simple in what you could feed it. You'd say add it as the event handler, and it would grab everything else it needed out of the macros and keep services running that needed to be, or do whatever it had to for them. And it would do things like it would restart it automatically twice, but if it had to do it a third time, it would just give up and let you generate an alert rather than try to fix it again. Perf data, yeah, perf data whenever possible. I guess I've always seen that having more performance data and trending is usually better. It's usually when things go wrong and you want to know why. Having that performance data can be very handy. And of course, like everybody else, we've got a lot of custom plugins for internal stuff and one-up things. Most of ours are in Perl. There's a few in C, but most I think are in Perl and some in Ruby now. Some of the changes we've had and some of the other add-ons, NRPE. Some people that have been using this for a while know that the buffer size is not that big. We actually had to patch it with a fairly big buffer size because we had some people trying to use it for what it was not intended for. We ended up having to use it in the event handlers to go out and fetch data and bring it back into the ticketing system. So I tried to convince them that it wasn't a file transfer protocol, but some people didn't agree, so we've got a pretty good sized buffer in there. So we use it to actually execute commands through some of the event handlers, and some of them go out, gather a bunch of data, and stuff it into the trouble ticket so people have more data right up front. NSCA, we're still using a lot of that. I'd like to potentially change that because we've seen a lot of issues with connections hanging, especially on the Windows side. We've noticed the Windows daemon, or the Windows exe is not all that good. Instead of rewrite it, I'd like to just get rid of it. But I've seen cases where if it had any kind of issue talking to the management server, it would just hang, sit there, eat up resources, and just not had a lot of good luck with it. We did end up running our NSCA through XINetD. We found that XINetD kind of helped buffer some of the incoming connections. So if you got a flood of connections, or if you got cases where we had some cases where there were some slower, like satellite links, and they would start to generate a whole bunch of tickets, and they'd open up a bunch of NSCA connections and then go away. and NSCA would just kind of sit there and hang, and then it would just kind of trickle down, and NSCA in general would start to kind of fall over. But by putting it through XINID would kind of orphan off those processes, and they didn't hurt anybody. So they'd hang around for a while. We had a process that would actually go back and try to clean those up after a while, but at least it didn't hurt anything then. A couple of the changes we ran into with XINID was the unlimited setting. In the documentation for XINID, it says if you don't specify number of instances and connections, that it's unlimited, and that's apparently not really true. We started hitting, I think it was about 10 or 12,000 connections an hour was the rate we could take on a single server before it started quietly dropping connections or refusing them. And it wasn't until we got kind of our first flood of problems that things kind of started to fall over. Once we actually went and specified unlimited, that rate went from about 10 or 12,000 an hour up to about 725,000 an hour. So we were able to push a lot more through it before it started having issues. It took us quite a bit to generate that kind of load too. So NS Client, that's another one we're using a lot of right now. We've kind of gone back and forth on whether we should upgrade. The upgrade to the newer version was quite a jump. There's also been a bunch of changes in our environment to do with Windows specifically, so we've kind of debated whether it was worth the jump or not. Plus going to potentially NRDP, not having to deal with it at all. So right now we're still using an older version of NS Client that we kind of patched with the bigger buffers for NSCA and NRPE. And it seems to work well on 2003 and 2008 servers, so we've kind of just left it alone for now. A large number of the Windows servers that were being monitored are going to be shifting over the next year to like a NAS device, which will be active checks through REST clients. So the amount of them will probably shrink dramatically over the next year. So another driver why not to do much with it, because it just works. So P&P for Nagios, we're using that, and one thing we have added was the RRD cache. That's helped with our disk I/O. We talked about doing some kind of central server with it, but again, it comes back to each server being its own standalone. It's done pretty well. We do rsync some of the data off once in a while, though, but we have a shared NFS spot that we put a lot of our backup files on, but we're not overly concerned if we did lose some of the performance data in the case of a whole server blowing up, which in the last 2 years I think we've only had happen twice. So not too overly concerned. It's not high on our priority list if we lost some of it. Some more of the changes from last year too. We were looking at DNX last year and had kind of started looking at Mod Gearman around the conference time last year. DNX we actually had pushed out to all the servers and kind of had there as a safety net if we ever needed it. When we started kind of trying to do some more testing with it, we had a lot of problems with inconsistent results and just the fact that the community seemed to have kind of gone away and there was really nobody to support it, no patches or updates being done. We kind of decided it was going to be a bad fit, especially as quickly as Mod Gearman was ramping up and maturing. We've kind of recently scratched it off the list. Given the changes in 4.0, we'd rather keep it all stock within the core if possible. So unless something weird happens, we're not really planning on either go down that route either. Live status is one we use a lot. We do a lot of queries against our servers to find out what's going on with them. It's a really great addition if you don't use it now. It's kind of like an SQL query language. You can query and find out all sorts of stuff about your server. If you go and print off the documentation, it's like an Excel doc that's like 12 pages long of all the different variables and stuff you can get out of it. So we use it in a lot of places. Even in our ticketing system, we'll query it and find out what servers are doing and what they have and that kind of stuff. So it can be some invaluable info. something we did right was a performance data that we were sending to Splunk. This is one that's actually, we kind of stopped using partially because we got rid of Splunk in a lot of places because of the amount of data it was generating. This worked pretty well, though. We just basically wrote an event broker that would just grab performance data coming in and send it right over a TCP socket right into Splunk. So there's almost no overhead on our server, yet it would gather all the stuff in Splunk and generate some pretty graphs and pie charts and stuff. A log separator. This was one that helped us a lot. We had some of our management systems would query the logs to find out what servers had been set up, what was going on, looking for what we have agents that when the agents get installed, they start phoning home to the management server they're supposed to be on, and the management server may not know about him yet, depending on the timing of when things got spun up. So they actually have a specific message that they would send in saying, hey, I'm here and I'm ready. So we were actually grepping for that, and if we could see it coming in fast enough, we would actually go ahead and activate it before the Puppet stuff came in and got it stood up. So one of the big things we found is with the size of our log files, the grep that was running even every hour would drive the CPU through the roof, especially by the time you got to like 11:50 at night, and your log file was already a gig in size. By the time you start grepping it, your CPU goes through the roof for 10 minutes while it tries to find that one thing that may have just come in. So by switching some of those messages off to individual log files, now we can just cat them, watch the epic timestamp, and parsing went to almost nothing for CPU overhead then. And of course the logs were a lot smaller, so that helped a lot. Puppet. Puppet is probably one of the key features to a lot of our stuff running. It automates keeping everything in sync, keeping services running, stands everything up. It is the major component of our DR. So if something blows up, we can easily just change host names, move stuff around, and run Puppet, and things are back up and running. It sounds like from the presentation earlier that the chef stuff works pretty close to the same way. So I think either one of them would work really well if you don't have something already. Splunk is really good if you can do it. It's really nice to have. When we had the data, we had some really nice queries set up that would watch for anomalies across the entire environment. And when we were first standing things up, it was a tremendous help because we could see, we could start to see when NSCA was starting to fall over. We could see those anomalous messages coming in about it timing out or dropping connections and missing data and all sorts of weird stuff that we could then go back and track down. And when we got 48 servers, 40 at that point, 36, 32, whatever it was, trying to watch the logs on all those servers is tremendous, especially when it's not only like varlog Nagios, but varlog messages, varlog secure, all the different logs everywhere. Cacti. We purposely went with the performance stats of Nagios itself outside of Nagios. The thought being that if Nagios was having performance problems, it might have problems logging its performance data. So we're using the Nagios stats template from Cacti, which loads a CGI on the server. But one of the things we changed is I think we got all but one of the checks converted to live status. So almost, because we also noticed another one of those things, whenever it ran that CGI, just pegged the CPU trying to pull all the data back. By moving it to live status, we couldn't hardly even notice any impact on the server at all. There was one calculated value that we worked with Matthias to try to come up with a way to do it, and it was going to be kind of painful, so we left that one. So we had one stat that it did pull, but otherwise wasn't too bad. One of the kind of more painful things we kind of had to do was develop our own control panel. And the control panel was mainly for managing host groups and templates and seeing where things were at. Because we had so many servers, most config tools know how to manage a server or a configuration. But they wouldn't allow us to easily say, I want, hey, let me throw a couple thousand over there, 300 here, 400 there, whatever. So just the distribution of everything and making sure you knew where everything was at, or in some cases where we would purposely add a whole bunch of servers at one time. So we ended up having to write our own control panel to let us do at least some high-level management. And sometimes we'd have some things we would know when hosts were going to be removed in bulk, and so we could move stuff around by hand that way. But yeah, that was one thing that we kind of hadn't anticipated at first was having to manage as much as we did through that control panel. We still do all of our configs and templates through VI from command line, and then push them into Puppet from there. But this helps us kind of manage where our hosts are distributed from. Console Labs, they do some really good stuff. We use quite a few of the stuff from them. So if you haven't looked at any of their scripts, they've got a lot of good stuff out there. And even sometimes when we've needed ideas on stuff, it's been kind of helpful, even if we didn't use what they had. So it's worth checking out. Some of the basic commands, if you're not too familiar with Linux performance tuning, some of these probably apply to other OSs. I don't know for sure. But some good stats to watch over: memory management, disk I/O. Top obviously watches a lot of stuff at once, mostly CPU and memory utilization, but can do swap and stuff like that too. IP trap is another one that I like for traffic management, so you can watch network stats as they're running. SAR, strace really isn't necessarily a performance tuning, but can really help if you're having plugins and stuff not working right. And ESX top for some of the VM stuff that we ran into. This explains a little bit about the environment. What we've tried to do with our host files was make a single file be a host. I think I have kind of one of the examples here. So we'll take a service group in this case. We give this service group name example. We have a host group name example. And then in the service, what we do is kind of tie the two of them together. So it allows us then to just add a host, which this host at the bottom would be in its own standalone file. So it made it a little easier to see what was out everywhere, push them around. And by just adding it to then the example host group gets all the service checks that are in there. So it makes it really easy to do some templating. And that's saved us a whole lot, so we can just add in the host group section. We usually just add in a whole list of all the different types of checks that particular server is supposed to run. If it's a web server, there's a host group for that. We can add that in. And so usually each service, there's probably each service group probably has probably 10 to 20 services in that host group. There's some that only have a couple of them, depending on what it is, but that's really allowed us to really just be able to push one config file for a host, and if that host goes away, we remove the one file, run Puppet, and its host is gone. So it's made management a whole lot easier. And the service group and host group names were pretty easy. We actually have a script that just scans the service files and look to see what's there, and it just generates those files for us in the background. So we don't even actually have to create the host group and service group files. It just kind of does it. So I guess this kind of explains a little bit. Some people still didn't understand after last year, so I did the slide I just showed, so it kind of showed some more technical of how it was tied together. Yeah, the limitations. Harder to do per server, per service customizations, which is one thing I've always loved about Nagios, is being able to say, this service on that server, these thresholds are different. You lose some of that granularity going this way, but we really haven't had too many issues with that in most cases. We've had to do some duplication of checks in a couple places so we could change thresholds a little bit for one particular application, but for the most part, that's worked out pretty well for us. Our hosts and built are signed through our control panel. So that's what one of our control panel things it does is the round robin distribution. So when you get a bunch of new servers that are coming in, it kind of goes out and looks to see, hey, where's everybody at? How many hosts do you have? It doesn't really look at CPU load or any of that kind of stuff. It assumes that the load, the number of hosts, is the determining factor. So we just look to see how many hosts it's got and goes on based on that. Yeah, our parents is what's the automatic stuff and what sometimes kind of bites us. It's the topology crawler that goes out and scans all the switches and tries to figure out where everything is at, and sometimes it's wrong. Or sometimes we'll see cases where servers are being moved to new networks, and somebody may actually like delete the server and leave the parent device there, and sometimes it's the other way around where they move the host but the parent's now gone, and so it gets confused to what's attached. Yeah, and the parents, we actually try to only ping them about once a day. We set the thresholds pretty low because we know that if there's a problem with the host or with the services, it'll start to ping and find out about the verification. So that way we're not constantly pounding network devices that aren't doing anything all the time. That's one of the things we don't actually do is we're not actually charged with monitoring network devices. We monitor them from the perspective of being able to do the correlation of parent-child device. So that was one of the things we were able to cut down quite a bit when we moved some of the stuff from OpenView, is our HP OpenView didn't understand that. And so they had to do some trickery to try to make it work, and the timing never quite worked right. So support staff was always used to running out and trying to figure out, well, what thing was actually down. And so this kind of just eliminated a whole ton of tickets right off the top. So that was pretty surprising to me that such a simple feature I'd been so used to in Nagios that something that we paid that much for in OpenView wasn't there. We do event handlers as much as possible. I'm a big believer in automation, so I don't like to actually go out and touch anything if I don't have to. Some of the things we're monitoring, a little bit of everything, probably standard stuff that everybody's doing, performance tests. We do some of these things we don't actually alert on, like NTP drift. It's more of an interesting fact to watch. We've had some cases where we've seen sometimes things got out of whack, and as some of you know, if you're using things like Kerberos, you get too far out of whack and things really start to fall over. So that was kind of the one big driver, is we wanted to kind of see over time how that was doing, and you can see some interesting stuff from that. Cron job completion is one that I know I've seen a lot of people not do. I've been kind of surprised that making sure that automated batch jobs and stuff actually work. Usually what we'll do with those is passive checks. So when it completes, it sends a passive check in, says, hey, I'm done. And then we use a freshness check that runs like every 26 hours to look to see if it's actually finished or not. That's been pretty helpful too. The Nagios config test that I talked about earlier, just making sure that the configs are actually still valid. Since it won't restart and break your config, we ran into cases where we found configs were broken and they had been broken for a while and we didn't even know it because it just all worked. So we had to put the config test in there to actually validate that servers were still actually happy and going. Most of the time we found that when the config was broken, the nightly crawler would actually fix it the next day, but not being able to update hosts on the server for a whole day can sometimes be bad. Watching the P&P for Nagios and check results files. You know, we kind of watch those directories to make sure they're not piling up because it's an early indicator that things are starting to fall over. Puppet update time is a pretty big one. We watch the state file. We make sure the state file is being updated all the time. Because if it gets out of date, then we know Puppet's not running. If Puppet's not running, files aren't getting updated, hosts aren't getting pushed out. It's kind of the core of everything. So we watch it pretty closely to make sure it's there. And event handlers to go and restart it whenever it thinks there's a problem. So DB response, Apache, kind of all the basic stuff. Some URLs for where we've gotten stuff. So where we're going next, one of the big things is 4.0. With all the enhancements and performance updates, we're really kind of focusing on 4.0 testing right now. We want to go there to kind of fix a lot of stuff. There's been some problems along the way. We had this one, which you can see was consuming memory at a pretty fast rate. This was on a virtual server that had about a terabyte of memory and 16-core CPU, and we managed to crash it. And all we were actually doing was just minus B. So, hasn't always been perfect, but some of our timing tests that we did came out really well. So the number of hosts and service checks, as you can see, we only went up by 10 at a time. And you can see some of the older algorithms, how fast how exponentially the number of seconds it took to run a verify on those got. And we could have gone further, but it was getting awfully painful to just sit and wait for these to finish. So we got to that point and stopped. But you can see the comparable times under 4.0 was tremendously better. And in the end, we took, and something we were never able to actually do was, at the time we ran the check, that's how many services we had, the number of hosts and service dependencies, and it finished in under 2 minutes, running a full verify. So it was pretty impressive to be able to actually do that now. For some of you that haven't seen, we've actually been running, this is the build as of this morning, earlier today. So I've got one of the demo systems we've been kind of playing with, and you can see so far the loads are almost nothing, even with all the processes, and you can see the child worker processes running. This is set to a check interval of 15 seconds. So it's only doing 2 basic checks right now, ping and a check TCP, TCP port 22 SSH check. So nothing too complicated, but it was more of kind of a, can we do a new build, push it out, run the build, make sure it actually works, doesn't core dump or consume all the memory and blow up or anything like that. So yeah, so far it's been pretty impressive that even just running this amount, like I say, you can see all the processes running, but it's consuming hardly any memory, hardly any CPU. Disk I/O is great. So really anxious to get it in next week and start doing some more heavy QA on it. So any questions?
Once again, you explained everything so perfectly that nobody has any questions at all. All right, how about a nice big round of applause for Daniel Wittenberg.